Alrighty, everyone. Welcome to Lecture 6, second part of the deployments lecture. So, we'll be going over how to actually take your applications onto the cloud and use Google Cloud and other services today. So, first off, a recap of what we did last lecture with containerization. So, containerization is just this process of packaging code into a neat, standardized unit of software so that's able to run on any machine regardless of the host operating system. We will be using Docker for our containerization. It's a better solution than using like virtualization, as we discussed in the past, of like how people used to deploy applications. And for us, we build code into images, Docker images, and then we can run these images as containers. And we push these images up to Docker Hub, as I hope you all did with your assignment and didn't find too much trouble with that. But now we will continue by taking an image that's now on Docker Hub and then bringing it onto a server that we can rent with Google Cloud and actually running our application live. So this gets us into the topic of deployment. So general approach, like what are we looking for? What are the things we're trying to accomplish? Is we want to have an application that's always running on the cloud, something that's always available, and if it crashes, we'll be alerted. We'll find a way to put it back up so that people who are using our application never have downtime. We also want our application to be open to receiving requests. It's publicly accessible on the web. We want it like our server not just like running our code in our computer, but it's actually out there and it's being utilized and being accessible for whatever clients are trying to interact with our API. And for us to actually accomplish this, we need to find hardware that's being maintained for us and is actually connected to the cloud and accomplishes all these things. Like if we're having our code running on our computers, it doesn't satisfy all these things that we want to actually have in a real application. So this prompts the need to go to somewhere else to find these servers. So in renting a server, we want to do this on the cloud. So we'll just run our containerized software as we would on a normal computer, but we're just going to be doing it on someone else's machine. So part of the reason we like to containerize is to limit all of these factors that go into running code so that we can bring it onto any machine and be confident that our code's running properly and everything's in order with that. So the reason we want to go to a service provider for this is there's a lot that actually goes into buying the hardware and running it and maintaining it, and by having a third party like Amazon or Google do this for us, it limits a lot of the work that we need to do, and people like us, students who are still learning all this for the first time, can still actually deploy applications on the cloud. So third-party providers, they have so many services out there. For us, some examples are like DigitalOcean, sponsor of AppDev, AWS, as I'm sure you've heard of, and then Microsoft Azure and Google Cloud, which we'll be using today. These are all like some of the big names and players, and they have so many cloud services to allow us to easily deploy and maintain these applications. So for us, we'll be using Google Cloud's Compute. So spin up a simple like server instance in a virtual machine and be able to go in the server and start running our code. So when we actually rent our server from one of these providers, we actually need a way to access this computer that we've just bought. And we do this with something called SSH. It's a secure shell protocol. It's basically how we can dive into computers that are like across the nation or across the world from our computer at home. And so SSH gives us the way of accessing a computer. Access means like opening and viewing files, actually being able to mess around with the file management system, executing commands to like install packages and actually run our software. And the way we do this is actually pulling up a console from the server that we're running. So here's an example of what this could look like. This is a screenshot I took earlier of my console actually when I'm SSHing into like the Eatery backend, for example. As you can see, I SSH into this server IP that I've labeled, and then it does a bunch of stuff. Basically, the big thing is at the bottom here, this AppDev at Eatery, and then the cache symbol, that's actually the terminal sign of the server. So if any of you are using the Ubuntu Linux VMs right now on your Windows, you've seen that cache symbol before because you probably have one too. And this means I'm directly logged into the computer, and I can mess around with common Unix commands like ls, cd, like pip install if I have Python, and I'm like literally directly in the computer. It's not physically right in front of me. So with SSH, people aren't just finding ways to dive into other people's computers all the time. There's a lot of security involved to make sure that this is working properly. So most common ways is to provide username and password credentials. Of course, when you create a new user. Also using public key pairs. So whenever you establish communication with a server, if it's the first time, it'll request that you like recognize the server and it'll add it to like some of your own local file systems. But this also creates a public key pair. I don't know if any of you have taken like CS 2800 yet, but talk a little bit about RSA encryption in that course and like public keys versus private keys and how you use hashes to keep track of like knowing who is who on the internet. So when we use SSH, we also create these public key pairs between our local computer and the remote server computers so that when we try to connect with them, that there's some communication, they can authenticate each other. Alternatively, we can also generate private key pairs. So these are very secret and we like to keep them very secure. So a private key pair allows us to kind of skip the username and password login. And as you saw, like at the top of mine, I indicated I'm using a server key pair with the -i server.pem. So that's a file I have in my local directory. And by accessing that file, I don't need to type in my username and password because it knows I have this key pair that knows who I am. So these private key pairs are like user specific. So each time, like each user will have a unique one, or you can have one key pair correspond with one user. In this case, this user is active, and eatery is the server name. So what this looks like actually in our command line, you can just SSH with a simple SSH command. Most computers should have this keyword already in their directory, and then user@server.com. So we actually don't need to use a domain after the @ symbol. You could directly plug in a server IP because the domain name ends up being translated into an IP anyways. That's what we'll be doing for the purposes of our servers. But users, you can do like root users, or you can make your own users when setting up your configuration with whatever virtual machine you're running on. And upon logging in, like I said before, you'll be requested to connect if you've never actually established a conversation between you two before. And then if you say yes, which you should, it'll add this public key pair to your known host. So you can actually find this known host file. It's in every computer in the /.ssh in your home directory, and you can navigate in that if you want to like learn more about it. But it's a way all local computers kind of just like keep track of what servers that they're aware of and keep track of those public key pairs. So once you're authenticated via your public or private key or your username and login password, then it actually opens up the computer for you and you can mess around with their terminal window. So for us, we actually will not be using SSH because we'll be using Google Cloud Platform's web terminal. It's a much simpler way of like skipping the whole SSH process by just logging into the Google Cloud website and then just opening a terminal window within the web browser. I don't know how they built it, but it's like really convenient for us. So we'll be using this for the demo and for the hack challenge when you deploy your applications. But if you do anything outside of Google Cloud, you'll most likely want to do SSHing. So that's why we like to talk about it and try to like make sure it's comfortable enough with all of you. You can also try SSHing with these Google Cloud servers you'll be running anyways. You'll have an IP and you can like test it out if you want to try it. But for us, we'll be using the web terminal because it's a lot easier for us to work with. Some other things you might want to do when you're deploying these applications is dealing with environment variables. So an environment variable is just some piece of sensitive information that we don't want to put directly into source code. Some examples of this would be like username and login credentials, other private keys or API keys. Like you wouldn't want to access, like say you're using like a Yelp API if you're doing like some food app and you want to like have access to the API, they'll give you a key, but you don't want to just like drop that directly in your code on GitHub because then the whole world can read this API key and then you've just broken that contract with Yelp. So we use environment variables that we can define in our local system that can be used in the code but are not directly like written down in the code. So we do this with what are called .env files. So you can name it whatever you want, but for us, we like to just use .env, stands for environment. And by accessing these environment variables in the code, it's just like accessing a dictionary. So like in Python, you can use like the OS library, and we'll go through some of this, but it has like this way to access the environment variables. And so when we use this on deployed servers, we don't want to, since this environment variable is not directly in the code, we actually need to, once we SSH into the server, create the same environment variable and define all these same things that we want to use in our application. And then also this gets into how we bring these environment variables into Docker containers when we run them. We use like an N flag when we run the containers, and you can also plop it straight into the Docker Compose. So this is like a basic synopsis of how we would deal with like a single server deployment structure, but I also want to talk a little bit about how we can optimize and further expand like our deployment structure with something called clusters. So clustering, big overview, just instead of having one server that does every operation, like running your application code, holding a database, and maybe even holding like some extra file storage system for you, we want to split up all of these tasks across many different servers and optimize those servers for those specific tasks and allow for communication between them so that we can even further boost our performance. And we can even do some cool things beyond just having individualized servers. We can do load balancing, which we'll get into later, but ultimately it's just about better performance. So this is like an example of what we could do currently. So we have a single server right now running a web application. For us, it could also be running SQLite, so it has its own database system. And then if we want to have file storage, like say something like Amazon S3, which purely specializes in just like storing large amounts of data and optimizing how you store that stuff, for us we wouldn't be doing this right now. But the point of clustering is to split these roles across many servers and allow for fluid communication between them, so that these processes can like happen seamlessly, and that this cluster of servers still looks like and functions like one system. So the pros of this, of clustering things and having multiple servers, is you can create a lot of redundancy and thus a lot of backups in your file storage if you want to have multiple copies of your database, so that if one crashes or something happens and it's all lost, you still have backup somewhere. You could also use it for resiliency for your web apps. So say there's an exception in one web app, but if you have multiple of them up at the same time, one can crash, but you still have some available to fulfill requests. For us also, it's easier to manage these systems by having everything independent. If you see like, oh, my server crashed, you don't have to go in and see like, oh, which part of its code that it was running did crash. You know, like, oh, the server responsible for the database, it crashed, it must be database related. Or for the application on the web, definitely something wrong with our code there. So by separating these on different servers, it gives us more modularity and understanding of what's actually going wrong if things do go wrong. And then the final point is about scalability and load balancing. So we'll go through an example of what load balancing really means. So imagine we have 3 servers running the same web application. We can use this load balancer up at the top that will receive the network traffic. And what it'll then do is split this network traffic between all of these different web application servers. So the reason we may want to do this is, in this example, we have 3 servers. It just basically cuts the network requests by a third for us. So if it's hard for a server, like if we have low CPU or not a lot of power behind each one, by just increasing the number that we have, we're able to fulfill more requests and lower the latency time between our clients sending their requests. So load balancing also gives us this cool thing where, say, we're getting a lot more network traffic than we were initially planning. Like, it's super huge. What we can then do is fluidly spin up some extra servers on the side so that we know we're getting a lot more traffic than we realize that these 3 servers can even handle. So we create some extra ones, and once they're done deploying, then we can have more to deploy to. So instead of splitting it by 3, in this example, we can split it by 5. Yeah. So all in all, like, clustering gives us the ability to have multiple servers working together to create a more stable and robust application. I guess any questions about deployment? I feel like I zoomed through some things. I'm sorry, but cool. All right. Well, hopefully some of this is cool. We actually will not be doing any load balancing in this class. We'll just be running a single server that will handle our database and our web application for us. But without further ado, we shall have Alicia get into the demo.
All right. Well, let's get started. Go to console.cloud.google.com. That's where we're going to set up our server. We're going to set up a virtual machine instant that's going to be running our server on it. So once you've made your account, before we run our server, deploy our server, we have to create the machine that it's going to be running on. So to do that, if you go to this drop-down navigation menu on the left side, and you scroll down to under this compute section, let me make this bigger. Yes, compute engine. If you look at the very top, it says VM instances. So we're going to want to create a new project, which will have its own Ubuntu VM. So before you do that, you have to create a new project. So to do that, you go to this top drop-down menu at the top here, right next to Google Cloud Platform. It'll have some, I don't think you guys will have anything, but you can just click this button right here that says New Project. So we can create a new project. I'm going to name mine Lecture 6 Demo. And I'm just going to go ahead and create that. So it's going to take a little while.
I have a question in the back.
Yeah, so if you go up here to this drop-down menu, if you click on it, there's a button in the top right of this card that shows up that says New Project. You don't have that? Oh, you want to take a look? Did you sign in with your Cornell email? While Connor is helping them out, once you press create, it might take a minute or two, but once it's done, you'll get a notification up here that will say create project, whatever you named it, and you'll have this dashboard with your project name and your project ID and some other stuff. All right, if you guys are still having trouble, you can stop by after lecture. Again, these videos will be posted online, so as I go through, if you ever miss anything, you can just check the YouTube video to catch up. All right, so once you've created your project, you should see this project screen that says Lecture 6 Demo. Some of you guys might be still creating it, but make sure you have your demo code loaded up, just meaning you have it, you've unzipped the file and you have, it should look something like this. You'll have your Docker file, your app.py, db.py requirements. This is just what we've been doing for the past few demos. Let me make you. Hello. It's a small boy. All right. Right, so now that we have that, our project set up, we can go ahead and create our VM instance, which we are going to run our server on. So you can go to the compute engine, which is down here again, and then go to VM instances. So the compute engine actually takes quite a long time to run. So again, we're gonna just have to wait. No. If you go to the left and then, yeah, under compute engine. So I guess while this is loading, I'll go ahead and build the Docker image again that we're going to be using on our server. So this is from the demo code. We have our Docker file, which I'll show you again. This is just exactly from lecture 5. And to build it, we can do docker build, and then we want to tag it. We want to tag it with the name that you used in Docker Hub. So for me, this is Alicia XW, and then whatever you want to name it. So I'm going to name it demo. And then we need to specify the directory, which is the current one. I've already built this, so it took not a lot of time. It was using the cache. If you have any changes, it might take a little bit. Yep. So it's docker build, and then we specify a tag flag, which is just going to be your Docker Hub name slash some tag name that you want to name it. And then the current directory, which is just dot. All right, I'm going to go back to the VM instance, so make sure you have that tab open. So compute engine is all done setting up. What we want to do is create a new VM. So press create. All right, so let's go through these. The name is just going to be something arbitrary. I'm just going to name it demo, and the region should automatically put you in like the East US, but I'm going to specify that here. So I'm doing the region is US East 1. We just want it to be close to us to make it fast. The zone doesn't really matter. For the machine configuration, this is a really small app, so we really don't need like a super powerful one. Also, like you can see the cost here, kind of pricey, which is why we're giving you credits. So for the machine type, the standard one is kind of large. We don't really need its computing power. We can instead use the shared core one that says G1 small. So for our boot disk, we're going to be Ubuntu. You can just press change, and it's going to pull up a list of OS images we can use. We're going to be using Ubuntu 18.04 right here. And you don't have to change anything with the size or boot disk type. So we can select that, make sure it's Ubuntu. We don't need to change the identity or anything. For firewall, we are going to want to allow HTTP traffic. That's what we've been using to send our requests in. So make sure to check that part. So again, to summarize, we have a name that you can just name whatever. We have a region, you want it to be on the US East. For the machine, you want the small machine here. And then for boot disk, we want Ubuntu 18.04. And then make sure in the firewall you're allowing HTTP traffic. So we can just go ahead and create. Oh. So you can see here in the notifications that's just getting set up. Cool. So now we have our VM instance. Again, this is using Google's resources, one of their machines that we can eventually mess around with and run our server on. So like Connor mentioned earlier, instead of SSHing into this directly on our own terminal, we can actually just access it through Google Cloud Platforms like web browser. So you can see here, I can make this bigger again, there's a connect that is SSH. But just on Google's web browser instead of our own terminal. So if you click that, oh, this is really small. It's going to take a little while to connect. Okay, can I make this big? It's really neat, actually. It literally will look just like terminal. I really don't know how they made that. All right, so you can see that we've connected to the host, and Ubuntu is running on this. Do you guys all have that up? Awesome. So,
Cameron.
Yep.
I have to create a trial to use the compute engine.
Did you redeem the credits? Oh, did you redeem it to the correct account? You want to help him? Which one? Oh, this?
Yeah.
Yep. Here's the command that we are using to build the demo code. Make sure you have the Docker daemon running. All right, so we're going to be wanting to run our server, which means we need Docker on this new machine. So this machine is completely unrelated, of course, to your local machine. So this doesn't have anything. It doesn't have Docker. It doesn't even have like Python. Well, maybe it has Python, but it doesn't have Docker. So we're going to have to install that ourselves. If you go back to the Piazza post, I link you two things, installing Docker on your VM and installing Docker Compose on your VM. So we're just going to quickly go through the steps to do that. So first, open up how to install Docker, which will look like this. Let me just zoom in here. There's really, we don't even need to read any of this stuff. A lot of it's already set up with our Ubuntu. All we're going to be doing is following step 1, which is literally installing Docker. And all we're doing is just going to be copy pasting these commands. So we're going to want to update our packages here. For those of you who don't know, apt is Linux's package manager, kind of like pip. And then I'm just going to take this next one and copy paste that. A lot of this is just setup stuff. If you fall behind me, you literally just follow the tutorial linked here. It's going to ask me if you want to continue. Say yes. Okay. Now we're going to grab our keys for Docker. And that just says OK. And then we want to add the repository to our package system sources. You don't need to know what these actually do. It's just there. Right? And then now that we have our Docker packages installed, we just want to make sure they're all up to date. We're not running an old version. So we're going to update, oh, I didn't want to do that. Update our packages again. Cool. This is just to make sure that we have everything installed properly. So when you put this in, you should see an output that kind of looks like a bunch of links and gets. That just means you have everything correctly installed. And then finally, we're going to be installing the Docker engine. So we want to continue. It's going to take a little while. So while this is loading, we can actually do this step 2. It says optional because it is optional. So you can find that on your own local computer, you can run Docker commands without having to do sudo most of the time. Sudo means you're running these commands under root privilege, which you can think of as like administrator privileges. But within this VM, if you notice that the prompt here is a cache symbol, that means you're just like a normal user. You don't have access to everything, aka you're not the root user. So when you're in this VM, you're going to use like sudo whenever you run Docker. And that's just because we're skipping this step 2 for setting up Docker. It takes a little while. All right, so now that we have installed Docker, we can just go ahead and install Docker Compose, which again, we're just going to a wonderful DigitalOcean tutorial and going through their step 1. So again, this is on the Piazza. This is the 4th link here. You can just open up, scroll to step 1, installing Docker Compose, and copy paste. I highly recommend if you're ever trying to set anything up server-wise, DigitalOcean is a really good resource. They have what I think are very straightforward tutorials. I mean, look at me, I'm literally not even reading anything, I'm just copy and pasting, and it works. So this part, we actually have installed Docker Compose, and we just want to make sure that it is properly installed. So if you do this Docker Compose version, you should see that you have some later version. Anyone have any questions so far? Okay, so now that we have Docker set up on our VM, we're going to want to pull the Docker image from Docker Hub so that we can run the server. Let's go back to our local terminal here, and you can see here that we already built our image. If we type in Docker images, I have already created this tag, tagged image. Yours should say created like, I don't know, 10 minutes ago or something. And what we can do is push it to our Docker Hub repository. So you can just do Docker push, and then whatever you tag this as. So you can see here that we're looking at which repository it's going to be pushing to. Once this is done, we can go ahead and go to Docker Hub here. And I already have my repository set up. We can see, this is really small. My latest tag that I just pushed a few seconds ago. So it should be updated after you push it. All right, so now that we have our latest version of our Docker image on Docker Hub, we can go ahead and pull it onto our VM. So how you do that is you run sudo, because we want to do this as root user, docker run, and then this is the interactive flag. We want to map the ports. So generally, we're going to use port 80 for one of these like server-side things. That's just because all HTTP requests are served on this port. It's kind of conventional to use 80 for HTTP, but you can use different ports for different things. Doesn't really matter. And then we're going to map it to 5000. And then you want to run the image that you just pushed. So for me, it's going to be aliciaxw/demo. So you see here that it says unable to find image locally. That makes sense because it doesn't exist on this VM. That's why we're pulling it. It's like if you use Git, you're cloning the repository for the first time. And again, you can see that there are a couple layers to this image, which is really nice. You can think of it as like layers of a cake. In the future, if you update any of your code and you're pulling the updated code, you'll see that it won't download all of these layers again because it already knows that you have most of these layers and it's only going to pull any of the code that you've changed. All right, so you can see that this is running on our VM. And if you go back to Google Cloud, you can see that there is an external IP. This is the public-facing IP. If you click on this, it'll take you to literally just the IP, and voila. If you remember the demo, the root route, which is just like the slash, is going to return all the tasks, and we haven't created any tasks. So this is exactly what we want to see. Anyone have any questions so far? Oh, I have like a Chrome extension that does that. It's very nice. So if you type in this, oh, yes.
So I didn't get the part. What do you do after pushing your demo file to Docker?
Right. So once you've pushed your image onto Docker Hub, you want to pull it onto this VM machine. So to do that, let me go back to the command here. Where? Am I being dumb right now? Where did I put this? Wait. Oh, it wouldn't show it. Basically, it is, it's like sudo docker run. So it's like the Docker runs that we've done in the previous lecture. And then -it, which is interactive. You want to be able to interact with the terminal. And then -p, which is the port mapping. And you want to map 80 to 5000. And then you want to do the name of your image. So for me, again, aliciaxw/demo. For you, it's your Docker Hub name / whatever you named it. Yep.
So for other projects, would we use the same VM instance, or are you supposed to make a new
No, you would make a new VM.
Okay.
Yep. Because if you are thinking about running say multiple containers, you would use the same VM, but for a totally different project, you would probably need a new VM. Yeah. All right, so I'm just going to keep going because we're a little short on time. Actually, I wanted to mention that this IP right now, since it's public, if you typed it in on your browser, you should be able to go ahead and access this. Generally, there are security things that you can put on the server such that not anybody can interface with it because you don't want any old app to get this data. But for now, it's just going to be public. So if you look at the VM, this still faces the same problem where you have to keep your computer open for it to work. If I were to exit out of this and then I try this public IP again, you see that the server is down. And like what Connor said earlier, we want the server to be accessed like 24/7 and minimize downtime as much as we can. And we can't just do that with like having it open on our computer. So again, this is where Docker Compose comes in. So let's create a special Docker Compose on our VM. If you do ls right now, you'll see that there aren't actually any files. But if you list all the files, they just have some stuff that you don't really need to care about. What we can do is create our Docker Compose file. So Nano is a type of text editor. Because you're in the terminal and you don't even have like Vim installed, Nano is like a preset that comes with Linux distributions. So if you just type in nano docker compose.yaml, it will create a new file with that name. It looks ancient because it is, but you can just start typing. So let's create a Docker Compose file, just like what we did in last lecture. So we want the version of Docker we're using, or Docker Compose rather, to be 3, and then services, or containers. I'm going to name mine demo, and then we're going to specify the image we want to use. For me, it's going to be AliciaXW/demo, and then we're going to want to specify our ports again. So that's going to be 80 to 5000. So this looks like exactly the same as our like sudo docker run command, except now we're putting in a Docker Compose file. So to save this, you want to do Control X, you can see it right here, exit. And then we want to save it, so just press yes. And then you can press, this is just letting you know that you've done this thing, and you can just press enter and it will save correctly. Cool, so now that we have our Docker Compose file, if you do ls, you can see it right here. Now we can do sudo docker compose up to start our server using the Docker Compose specifications. So we're creating this demo 1, and again we see on the left here that this is our instance, and we have the output as expected. If we go back to our IP address, here we go. So note that a name is given on the left to the instance because in Docker Compose, again, you can run multiple instances of the same application. So say if we ran like 3 instances of this application, we would have like demo 1, demo 2, demo 3. And this suffers from the same fate where if you quit out of it, then the server stops running. So if we quit out, remember that we can run these in detached mode, which is just like code name for saying we can run this in the background. So if you Control C, it's gonna gracefully stop. And we can do the same thing, but specify detached. So now it's starting it. If we do docker ps, showing us all of the running containers of sudo docker ps, then we see that we have, oh, this looks whack. Whoop. Oh, whatever. You can see that AXW5, that's me, the demo is running. And then, awesome. So to end this off, it's good that you have this deployed. This is basically like the very bare minimums of how you would deploy your code. It's up. I don't even have to have this open or the SSH thing open if I didn't want to. And we can make requests to this and do what we want. But you guys are going to be updating your code a lot. During the hack challenge, you're going to be building, you're probably going to break something, you're going to have to redeploy. So what does redeploying like new code look like without having to go through all of this again? That's what I'm going to show you right now. So say we go to our app.py here. This is back in our local terminal, by the way. And say that we want to change one of our routes. So let's say that right now both this root route and this tasks route will both get tasks, but say we want like a little hello world message at this root route instead. We can do something like define hello world. And then instead of returning the tasks, we can just return hello world. And success. So we've made a modification to our code, and we want to redeploy it so that everyone can access this update. It's very similar to what we did to initially push our code and deploy it. First, we have to rebuild it. So you can do docker build, and then tag it the same thing you tagged before. And you want to build the current directory. It should be pretty speedy because it's using the cache. Cool. And then now we want to push our newly built image back to Docker Hub. So docker push, and then my tag name. And it's smart. It knows that these layers already exist. So it's only going to push these top 2 layers. All right, it says it's pushed. If we go back to Docker Hub, we should see that our latest version, again, has just been updated a few seconds ago. All right, so now if we go back to our VM, so we're still running the server right now. When we update it, we're going to want to stop running it first. If you may have had the problem where you have like the server running and then you try to run it again and it'll say like port already in use. That's because you can't have 2 applications listening on the same port. So that's why we need to take down this running container. So you can just do sudo docker compose down. If docker compose down is too slow for you, you can either Control-C or you can do like docker kill container ID, but you generally don't want to do that. It's not very safe. You want to let it take its time. All right, so now we want to get this new updated image from Docker Hub. So same thing as before. We want to do sudo docker, and then we want to pull the new update in. So saying it's pulling from the remote repository. Very cool. Now again, if we do sudo docker compose up and then detached, we go here. Oh, it says hello world now. Good stuff. All right, so one last thing. Remember what we were talking about before with environment variables. So I'll give you a quick example of what that might look like in your application before I show you how you would deploy it inside of the VM. So say that in our local code, let's take a look at it, app.py. So right now we're returning hello world, but what if we wanted to set an environmental variable and then return whatever that is? So it's not going to be hard-coded in your app.py. It's going to rely on some like environmental variable file that we define in the directory. So how do we do that? Let's just say we create some secrets file. So we have secrets.env and say that, so realistically you would probably use it for like API keys. If you use like Google API, you might use one of their API keys like Google Client ID. And then it would be some complicated string. I'm just going to call it hello world. So again, Google Client ID, that's the example I'm going to be using right now. So to load this into your environment, you have to do something called source and then secrets.env. So this is just loading it into like your command prompt. That way, you can check if this has worked. If you do echo $, and then the name of the environment variable that you want to check. So in our case, it's Google Client ID. So it returns hello world. That means the terminal recognizes that this is a variable. All right, so now if we want to use this in our app.py, we can just go to app.py, and how you import environment variables in Python is you can do import OS, so operating system library. And then here, instead of return hello world, we can do something called return os dot so environ, which is like the environment variables. It's going to be like a dictionary, and we're going to get the Google Client ID, and then return status code 2000. So in case we want to check that that works locally, we can just run python 3 app.py. So this is running on localhost. Oh, my bad. I think if I go into the secrets.env, I want to do export. So the difference between just setting the environment variable versus putting export in front of it is that export will allow you to like see the environment variables in sub-processes outside of the terminal. Hey.
So just quickly, what did you do in app.py again?
Yeah, let me go back to that. So I imported the OS package, and then inside of the hello world route that we created, I'm just going to return the value of Google Client ID, whatever that maps to in our secrets.env. So it's os.environ, and then the variable, and then I'm returning a status code. All right, so let me just source it again. Source secrets.env, and then I'm going to run my server. Hopefully this should work. Hello, world. Cool. So that's convenient, and this is extra convenient when you actually want to use API keys other than just hello world. But how do we get that into our VM? What we can do, so we've made some changes to our code. So again, we're going to do what we did before, docker build. We're going to build our new image. All right, and then we're going to push it to Docker Hub. I know a lot of this is probably repetitive, but it's a little, like the learning curve to do Docker stuff is a little steep, so we want to make sure you guys have as much practice as you can, especially when you start working on your hack challenge projects, and what you work on is not going to be like cookie cutter from the demos. All right, so that's uploaded to Docker Hub. If we go into our VM again, now we're going to want to docker pull sudo and now we're going to want to use the secrets. So first of all, the secrets file doesn't exist in here. We're going to have to create it, and that makes sense. So let's do that. Nano secrets.env. And now we're going to want to do Google, I think it was Google Client ID that I said. Hello world. Note that I didn't put export in this one. So the reason for that is because we're going to load our environmental variables in, not from just doing like source inside of this terminal, but rather from the Docker Compose file. And when you do that, Docker Compose requires that the env files be formatted exactly like this. It's like variable equals value, variable equals value. There's no export or anything. So this isn't like a bash thing. This is like a Docker thing. So again, to save, you want to do Control X, you want to press yes, and then enter. So if we look here, we have a secrets. The reason why we want to recreate the secrets is because if you use like your server locally versus you use it like in a production server, the secrets are generally going to be different. You might want a different password for like a different database you're using. So that's why we specify it manually within like our VM. So then we can edit our Docker Compose. And we are going to want to load in our new environmental variable file. So that's specified if you just do env file, and then you can specify secrets.env. Pretty simple. All the stuff you can find on the Docker Compose documentation. They're pretty good about that. So let's save it. All right, and then now when we do, let me make sure that nothing is currently running. PS, so something is running, so let's pull that down. Compose down, not composer. What? So let's stop our currently running one. Now that we've pulled the new image in with our new like environmental variable route, we can go ahead and start that one instead. So we can do sudo docker compose up detached. And instead of going to our local host, we should be able to go to our external IP address, and then now it reflects our environment variable. So yeah, that should give you most of the tools you need to deploy. So the assignment this week is just going to be taking the Docker image you built last week and putting it on Google Cloud.